All right, question one. What are the letters that we use in algebra called? Well, I know they're not coefficients because coefficients are the numbers that sit in front of pronumerals. Like in 2x, the coefficient would be 2. I know they're not equations because equations are just expressions that have an equal sign in it. And I know they're not constants because constants are numbers on their own that don't have any letters. So that leaves me with pronumerals. So the letters we use, like x and y and all that kind of stuff, are called pronumerals. In question two, we want to know, are these like terms? Well, I'm looking for the pronumerals here. I need them to be the same. For these things to be like terms, they have to have the same pronumerals. In this case, they're both k. So yes, it's true. They are. If I had, I don't know, let's say k and k squared, then no, they would not be like terms. Or if I had, say, k and km, then no. But in this case, I've got k and k, so they are like terms. Okay, is this an example of an expression, a constant, a term, or an equation? I'm going to tell you straight up that the answer is D. It's an equation because it's got an equal sign in it. Just like the word equation starts with the same letters as equal. So that's how I know. The reason it's not an expression would be just this part here. So 3m minus 12 is an expression. There's no equal sign, so that we say that's an expression. The constant are just the numbers on their own, and a term are the parts that make up an expression or an equation. So in this case, 3m would be a term, negative 12 would be a term, and 18 would be a term. So our answer in this case is an equation. How many terms are in this expression? Now, I'm going to give you a little tip and trick here, is that when you're breaking these up to count the terms, don't forget to include the sign. So the first term is the first bit before we come to the first plus or minus sign. So in this case, 4x squared is a term. As soon as we hit a plus or a minus sign, so I've got a negative sign here, I've got a plus sign here, every time we hit one of those, pretty much that's where the next term begins. So my terms in this case are 4x squared, negative 2x, and plus 12. They are each of the terms in this expression. There are, in fact, 1, 2, 3 of them. So there are 3 terms in this expression. All right, what's the highest common factor of 21 and 6? So the first thing we want to do is look at the factors of both. So the factors of 21, in other words, what whole numbers could fit neatly into 21? Well, 1 fits in. 2 doesn't, but the next one that does is 3, because 3 sevens are 21. 4, 5, 6 don't, but 7 does, because 3 sevens are 21. And 21 is also a factor, because 21 fits in. So the factors of 21 are 1, 3, 7, and 21. The factors of 6 are 1, 2, 3, and 6, because each of those numbers would fit neatly into 6. All I want to do is go through and see which number is common to both lists and which is the highest number that is common, because 1 is both common, right? So 1 is on both lists, but it's not the highest number that is on both lists. It is, in fact, 3. 3 is a factor, it's a common factor to both of those numbers and is the highest. So we say the highest common factor in this case equals 3. In other words, the biggest whole number that fits into both of those is 3. All right, what's the coefficient of x in this equation? Now, a coefficient is just the number that sits in front of this pronumeral. So in other words, in our equation here, what's the number that sits in front of the x? Well, as I have a look, it's pretty straightforward. It's 3. So we say the coefficient of x is 3. Is this true or false? Now, probably you could probably try and just do this in your head just looking at it, but if you get confused or if you're unsure, I would suggest go through first of all and just put all your letters in alphabetical order. These are all being multiplied. So remember, we can multiply numbers in any order. We call that the commutative law. In other words, 1 times 2 times 3 is the same as 3 times 2 times 1. So because they're all being multiplied, I can move them around. So I'm going to rewrite this as a times a times a, because I've got 3 of them. There's this one, and this one. And then I'm going to put my m's back in, of which there are 2. So I can rewrite it in this. It's the same thing. Now I can go through and see, well, I've got 3 of those and 2 of those. And because they're all being multiplied, I can simplify them to read a cubed times m squared. And remember, we don't have to put this multiplication sign in, so we take it out. I've just got a cubed m squared. Is that the same as what we've got up here? Let's have a look. A cubed m squared. The answer is true. It absolutely is. This question, question 8, is just a nice, simple substitution question. It's a really small expression, but you do need to know how to substitute. So in this case, I've got 3 times x. All right, that's the expression that I've got. And I'm being asked to substitute when x equals 5. What that means is replace the x with the value of 5. Please do this. Get in the habit of creating a space with the brackets, and there's a number of reasons for that we've talked about in other lessons. And then simply put into that space the number you're substituting in this case 5, and I end up with 3 times 5, which is simply 15. So when x equals 5, our expression has a value of 15. We're looking for things that are like terms. Now remember, like terms here means they have the same pronumerals or the same letters. So we can instantly rule out that one and that one because x's and m's, b's and a's are completely different. This one I've got a bit of a question mark over because the letters are both a's, but you have to remember a and a squared are not like terms. One is a, one is a times a. So that leaves me with my correct answer, which is 4x and negative 2x, because they've both got x's as their pronumerals, which are like. All right, let's expand 6 outside of x minus 3, and we're going to use the distributive law, which means, let me do this example here. We're going to take the number outside the front, or the letter, whatever's outside the brackets, and we're going to do 2 multiplications. First one was we're going to multiply it by the first term inside the brackets, and then by the second term. So in this case, I get 6 times x, because I do this bit first. So 6 times x gives me 6x. Then I'm going to take the 6 and multiply it by the next term. Now the next term isn't 3, the term is negative 3, because remember, we take from the start of the sign. So in other words, 6 times negative 3 gives me negative 18, because a positive times a negative gives me a negative result. I've expanded that to 6x take 18. All right, factorise 3y plus 9. Remember, we're looking for, when we factorise, something to pull outside that will go outside some brackets. And the thing we pull out is the highest common factor. In other words, the biggest number that fits into both this term and this term. So something that fits into both of those would be 3. So I'm going to pull 3 outside of the brackets. The bit that goes inside the brackets is simply what I need to multiply 3 by to get each of these terms. So 3 times y will give me my 3y. So the bit in the brackets becomes the y. What do I multiply 3 by to get a positive 9? Well, the answer is 3. That is my factorization. I can check it by doing the reverse and actually doing the expansion. So multiply 3 times y, multiply 3 times 3, and let's do that. So if I expand that, I get 3y plus 9, which happens to be the same thing as what I started with, so that's awesome. So our answer is this, 3 outside of y plus 3. Okay, we're asked here to write an algebraic expression for the perimeter, and we're told in the question, in case you've forgotten, that the perimeter is just the distance around the outside of a shape. So if I started here and I went around this shape back to the start, that would be the perimeter. And I just add all those together to get my perimeter. So I'm going to start at the B, so I'm going to start the first bit of my journey, which was along this side, is B, plus A, plus another A. So I could write that as B plus A plus A. Now, are there any like terms in this expression? Yeah, I've got A's which I can add together. I've got 1A plus another A gives me 2 A's. My B is not a like term. So the answer, an algebraic expression, is 2a plus b. The coefficient of b. Now remember, coefficient is just the number in front of the pronumeral, but be careful, I'm not looking at this one, right? Because that is a b squared, not a b. I am, however, looking at this one, and I need to look at the sign and the number. So the coefficient of b, in this case, is positive 2. Let's simplify this expression by collecting the like terms. Now remember, like terms just have the same pronumerals. So the first one I can see is this one, 7n. Because I've also got another term in here that has an n in it, and it's this one, minus 2n. The m here is not a like term. It's an m. It's completely different. It doesn't have this same pronumeral, so I can't do anything with it, but I can collect these. So I've got 7n. I take away 2n, which leaves me with 5n's. Start with 7, take away 2. The plus 3m remains, so I leave it back in, and that is our simplified answer. When you're asked to solve an equation, all that means is find the value for the letter you're solving for. So in this case, we're solving for m. So my answer is going to end up m equals something. So that's my goal, is to go through and use my algebra skills to get it down to that. So I'm starting with 4m plus 9 equals 15 plus 2m. I'm trying to get m on its own, so I need to start to clear some things away. I would like to get rid of this 2m for starters, because I've got m's on both sides. That's not going to work. Let's get rid of these. The opposite of adding 2m is subtracting 2m. Remember, whatever you do to one side, you have to do to the other. So in this case, I'm going to take away 2m's from both sides. This means they cancel out. We call that a zero pair. So they're gone now. So what do I have on my left-hand side? Well, I've got 4m take 2m, leaves me with 2m, and the rest I haven't touched. So that all stays the same. Good, we're getting there. Now I'm trying to get m on its own here. So I want to get rid of this plus 9. The opposite of plus 9 is take 9. I do the same to both sides, so I've got a zero pair that cancels out, and now I'm left with 2m on the left hand side, and on the right hand side 15 minus 9 equals 6. The last step here is this means m times 2. Right? That's what 2 times m is. So the opposite of timesing by 2 is divide by 2. Whatever I do to one side, I do to the other. These two now cancel out, and I'm left with my solution, which is m equals 6 over 2, which happens to be 3. The solution is m equals 3. We've got a couple of steps in this question. Part A says make t the subject of the equation. So we've got this equation here. C equals 20t plus 2,000. This is the cost for hiring a hall. So let's take that and let's do that over here. I've got C equals 20t plus 2,000. Now, to make t the subject of the equation, I'm going to have to end up with something that says t equals. That's my final goal. So I want to get t on its own. We just use our algebra skills to do that. So trying to get t on its own, first thing I want to do is get rid of this 2,000. The opposite of adding 2,000 is minus 2,000. Whatever I do to one side, I have to do to the other. They cancel out because they're a zero pair. Now my left hand side looks like c minus 2,000, and my right hand side just has the 20t left because this other stuff got cancelled out due to the zero pair. The last step is to get rid of this 20. Now this is t times 20, so we do the opposite. The opposite of timesing by 20 is divide by 20. Remember, whatever I do to one side, I have to do to the other. And when I do this, I divide the entire left-hand side by 20. These cancel out, and I'm left with t equals, because I'm just going to swap these left to right, c minus 2,000 all over 20. And I now, excuse me, I've made t the subject of the equation because my equation says t equals something. Now I can use that for part B. Because part B asks me to work out what t is when I have a certain value for c. In this case, my value for c is 2060. This becomes a substitution question. So my equation from the previous part was t equals c minus 2000 over 20. I substitute, so I'm going to create a space where the c was because I'm replacing that with a value. And then I can put that value in. In this case, it is 2060. And now I can simply calculate that in my calculator or in my head. I've got 2060 minus 2000 all over 20. That works out to be 60 over 20, which works out to be 3. So I could hire the hall for 3 hours. Let me see what the question said. So here, when c is 2060, t, or the time, in other words, the number of hours for which the hall is hired, would be 3. Okay. There's a couple of questions around this table, so let's have a look at them. First one is, which is the dependent variable? Usually in these, it's the one on the bottom. It's the y, because our x values, we can pick whatever we want. They're independent. But our answers for y, after we do the substitution, will depend on the x value we put in. So these are the dependent values. So in this case, I would say y is the dependent variable. Question 2, complete the table. Each time we go along, this is just a substitution. So in this case, I'm going to take an x value of 2 and substitute it in here. So I end up getting something that looks like this. Y equals 2. Remember, leave the bracket space, put the value in. So I'm going to put an x value of 2. So y equals 4 minus 4, which in this case equals 0. So I put it in there. So what that means is, whenever I've got an x value of 2 and I substitute it into this equation, I'll get a y value of 0. Let's see if we can erase this. And then now I can do the next value. So in this case, when x equals 3, I get, when I substitute that in, create the space, put the 3 into that space, I get y equals 6 minus 4, which equals 2. So when x equals 3, y equals 2. And if I repeat that process, I'm going to get values of 4 and 6. I've now completed the table. The common difference, or the constant difference, is the amount that this value increases by each time. And I can see they're going up by 2. So the constant difference is 2. Because every time I go up 1 in my x, my y's increase by 2. Graph the function. All right, I only need 2 points. I know it's a linear function, so I can just do this with 2 points. I know it's linear because there's no x squared or x cubed. The highest index here is x to the power of 1. So I just need 2 points, but I'll go through for the sake of completeness and put them all in, because each one of these points here represents a set of coordinates. That's the coordinates 1, negative 2. This is the coordinate, whoops-a-daisy. This is the coordinate 5, 6. So I can just go ahead and plot them onto my chart. Now remember, when we're plotting, we do the x value first. So I go across to 1, down to negative 2. Always do the x first, so I've got a point there. My next coordinate is the point 2, 0. So I go across to 2. I go up nowhere because I'm going up to 0, so I don't actually need to move, so it's right there. My next coordinate is 3, 2. So I start at x, I go across to 3, up to 2, and I plot my point right there at 3, 2. And I repeat the process 4, 4, gives me 4, 4, and the last coordinate 5, 6 puts me there, and you'll see that they are all in a straight line. Let me see if I can draw that, which I can, and I've now graphed the function. I just plotted the points, joined them with a line that went through, so we've now done that. Use the graph to determine the value of y when x equals 7. Now, bit of a boo-boo, I should have drawn my line a bit longer, so let's see if we can extend it. Alright, I've just extended that line because we need to look for the point to find the value of y when x equals 7. So all I do here is I come across to where my x value equals 7, and then I go up till it hits the line, and then I come across to get the corresponding y value, which in this case is 10. So when x equals 7, go up till I hit the line, come across, y equals 10. So the answer is y equals 10. Okay, so I'll draw that on. So if I go up from the x equals 7, and then where I hit the line, I come across to get the corresponding y value. In this case, it's 10. What is the value of the y-intercept? Well, once again, I'm just going to extend my line because I was a little bit short. The y-intercept is where it cuts through the y-axis. And I can see at this point that the value of the y-intercept is down here at -4. This is where it cuts the y-axis. All done. Good job. Alright, simplify this. Well, I could rewrite this simply. 3ab means 3 times a times b. That's that bit. And then I've got another times b on the end of it. Now I've got 2 of these b's, so b times b gives me b squared, so I get 3 times a times b squared. Finish up by taking out the multiplication signs because we don't need them here. So my answer is simply 3ab squared. Alright, we were asked to do this expansion. It's the distributive law where we take the number out the front of the brackets, and in turn we go through and multiply by each of the terms inside the brackets. So in other words, my first multiplication will be that, my second multiplication will be that, and then my third will be by, the -3. Okay, so I'm going to do each of those, and then I can just tidy up at the end. So let's go through. First of all, I've got 4 outside of x plus 2y minus 3. I'm just rewriting the question. 4 times x, so that's this bit times this bit, gives me 4x. 4 times positive 2y, or plus 2y, gives me 8y. And that's positive, because a positive times a positive is a positive. And then I've got 4 times -3. Now remember, a positive times a negative gives me a negative answer, so it'll be -12. That's it. There's nothing else to tidy up. I've got no like terms to tidy up, so we've expanded that. All done. Now factorizing is just the reverse of distributing. So we're going to end up with some brackets and something outside the brackets. But what goes outside the brackets? Well, it is the highest common factor of each of the terms. Now remember, we said the highest common factor is the biggest factor, or the biggest number that fits into both. So I'm looking for a highest common factor of 6m and -18. So is there a number that fits into both of those? Well, as I look at it, I can tell that the answer will be 6, because 6 fits into 6m and 6 fits into -18. That highest common factor is the number that goes outside my brackets. So I'm going to start with 6, and then I'm going to have some brackets. Now what goes inside the brackets? Well, the bit that goes inside the brackets is whatever I need to multiply 6 by to get this term. So 6 times m will give me 6m, so the first part of my brackets will be m. What do I need to multiply 6 by to get -18? Well, it'll be -3, because a positive times a negative gives me a negative. So 6 times -3 gives me this -18. Now I could check that by actually expanding it. So if I was to do the expansion, I'd go 6 times m gives me 6m. 6 times -3 gives me -18. That happens to be the same thing as what I started with, so that means I did it correct. My factorization, what's am I doing there? Let's undo that. The factorization is that 6 outside of m minus 3. I'm just going to write that neater because I felt like I made a bit of a mess there. That's your answer. 6 outside of m minus 3. Alright, we're looking for the coefficient of AB in this expression here. Now this is not it. This is AB squared. So 6 isn't going to be it. We're looking for the number in front of AB. This is the pronumeral, AB, or pronumerals. So we're looking for the number in front of it. Now be careful, the answer is not 8. Even though 8 is in front of it, we need to take the whole number in front. So in this case, the coefficient of AB is -8, okay? All right, let's do this simplification. Now, I'm just going to do it kind of like the short way, and then I'll do a little bit of a longer way for those of you who maybe struggle with the short way. Now, I can look at this and know I'm going to do the numbers first. So -6 times 2 gives me -12. Okay, that's -6 times the 2. Next, I'll do the a's. I've got a squared times a, which will give me a cubed. And then finally, I've got b times b, which gives me b squared. That's my answer right there. Now, I'll do a slightly longer way. If you got one that you couldn't quite do in your head, or you needed to just think it out a little bit more, you could write these in expanded form. So you could write -6 times a times b, right, which is this bit here, written in expanded form, and then expand the next bit. So times 2 times a times b. Next thing is put everything in order. Numbers first, so -6 times 2. Put all your letters in alphabetical order. So that's a times a times a, because there's 3 of them. That's these 3 here, 2 and 1 more. And then finally your b's. And now I can go through and tidy all that up. -6 times 2 is 12. A multiplied 3 times gives me a cubed. And b times b gives me b squared, which all tidies up to be that, which is the same thing we got up here. We just went through a few more steps just for those of you who needed to see it a little more clearly. All right, here I've got a graph that's showing my business where I'm growing and selling roses. And I've got 2 equations being graphed on the chart here. One that shows my income, so how much I make from selling the roses, and another that shows my costs, how much it costs me to make the roses. Remember, we said 2 equations being graphed together are simultaneous equations, and they have some important information they can tell us, particularly at the point where they intersect, and that's what we need to know for question A. It asks, what number of roses do we need to sell to break even? Now, the break even point, if I just zoom in, sorry, let's get rid of that. If I just zoom in here, make it a bit easier. The break-even point on a simultaneous equation like this is the point where they intersect. So in other words, it's right here. This is the point where my income and my costs are the same. In other words, I break even. I don't make or lose any money. From here, I can drop down and see that the number of roses I need to sell at that point is 2. Okay, 2 roses is the break-even point. The number of roses is 2. So the answer to my first question is 2. I need to sell 2 roses to break even. How much profit or loss is made when 1 rose is sold? Okay, let's zoom in again and have a look. When 1 rose is sold, then there's some information I can read off the graph. So when 1 rose is sold, that's this point here, I can read up along this line and say, well, my income at that point is $20. So for 1 rose, I go up till I hit my income line and come across. So I've got an income. So for 1 rose, my income equals $20. In other words, I've earned $20 from selling 1 rose. However, at the same point, if I go up along here until I hit the costs line, which is this red one, I can see my costs, if I come across, are somewhere around about the $30 mark. Okay, so it's 30 in there. So I've got a cost of $30. That means I've spent $30 to produce this rose, but I've only made $20 from selling it, so I've made a loss of $10. That is represented by this section of the graph here, the distance between my income and my costs. So in that case, I can say the loss I've made on 1 rose equals a loss of $10. Okay. How much profit or loss is made when 4 roses are sold? Well, let's do the same thing. Let's zoom back in and let's have a look at 4 roses. So at 4 roses, I can go up along here and I'm looking for the distance between the 2. In this case, I can see my income is higher than my costs. So in that case, I'm going to make a profit, because if I'm earning more money than my costs, I'm going to make a profit, and the profit is this distance here. I can look at my graph and see that goes from 60, All right, so at this point, my costs, so for 4 roses, my costs are $60. But my income for 4 roses is actually $80. So I've made a profit of $20. So I could say with 4 roses, oops, daisy, and 4 roses, let's try that again, I make a profit of $20. Finally, what are the initial costs? Now, hopefully you remember the initial costs are the startup costs, or they're the costs at the start. So if I go and say, all right here at the start, before I've even sold any roses, do I have any costs? Well, I go up and I can see that my costs line cuts through here at $20. So my initial costs, in this case, are going to be $20. So my initial costs are $20. Now that might be things like, buying some materials or setting up some space to work in or having to rent a shop, that kind of stuff. So even before I've sold any, there'll be costs that I incur. In this case, it's $20. All right, we're asked to solve this equation here. It's just an algebra question where we're going to use some of our algebra skills. It looks a little bit ugly, but we're just going to work through step by step to solve this. Our goal for solving is to get the pronumeral on its own. So our answer will be u equals something. That's what we're trying to get to. So we need to strip away everything around the u until it's on its own. First thing I've got going on here is I have a look. U plus 3 divided by 5. This is divide by 5. So I'm going to do the opposite. The opposite of dividing by 5 is multiplying by 5. I do the same to both sides. So I'm going to multiply this side by 5. This side I'm going to multiply by 5. And I'm going to do it in brackets just to remind me that I'm multiplying the whole lot by 5. But that gives me stuff I can cancel out now because I've got 5 on the top and bottom. So I can cancel them out. My left-hand side looks like u plus 3. And my right-hand side now is 4 times 5, which is 20. Last step, I want to get u on its own, so I want to get rid of this plus 3. The opposite of plus 3 is take away 3, do the same to both sides. They cancel out now, that 0 pair. And my left-hand side is u, my right-hand side is 17. I've solved it. U equals 17. All right, this question's got a couple of parts to it. Expand, first of all, and then simplify. So let's go through it. Remember, expanding just means we're going to multiply the value outside the brackets in turn by each of the pieces or each of the terms inside. So that's going to get us something like this. Negative 7 times n gives me negative 7m. Negative 7 times negative 3. A negative times a negative makes a positive. So that will become, positive 21. And the rest, I don't need to expand. It's already just written in a form that I can just copy that straight out. Okay, now this is where the simplify part comes in. We've done the expanding, now simplify. So we're looking for like terms or constants that we can tidy up by bringing together. Well, I've got two like terms here. This is m and this is m. So I can bring them together. Negative 6m plus, negative 7m plus 6m. When I got them together, that leaves me with a negative 1m, because negative 7 plus 6 is negative 1. My numbers I can tidy up. I've got 21 plus 12, which gives me 33. So the answer is negative m plus 33. All right, fully factorize this. Now, I'm looking for the highest common factor. So something that fits into both 6p squared and 3p, and the highest thing that will fit into both. Probably a way to think about this if you're not sure is maybe just write these out in an expanded form. So I'm going to rewrite 6p squared as 3 times 2, because they're the factors of 6, times p times p. The other part is 3 times p. So I'm looking for some common factors. Now I can rewrite this in any order I want. So really this becomes the same thing as 3 times p times 2. Now the reason I do that is because now I can see that there's a common factor. I've got a 3 times p here and a 3 times p here. So the highest common factor is 3p. In other words, 3p fits into 6p squared and it also fits into 3p. So I'm going to put that outside my brackets because the highest common factor goes outside the brackets. What do I have to multiply 3p by to get 6p squared? Well, it happens to be 2p because it's the bit that's left, isn't it? Okay, because if I multiply 3p by 2p, I get 6p squared, which is this piece. What do I multiply 3p by to get 3p? Well, the only bit that's left is 1 here, okay? Because 3p times 1 gives me 3p. So if I expanded this out, I would get this, which is the way I can check that my factorization was correct. So just going through those steps again, I found the highest common factor. I expanded these out just to help me identify what that was if I wasn't sure. And I could see that it was 3p, bring it outside the brackets, and inside the brackets goes the bits that I need to multiply this by to get to this. All right, another perimeter question. Remember, the perimeter is the distance around the outside of a shape. So if I took a journey around the outside of this shape, and even though the factors, the values aren't on here, I can put them in to help me understand that by doing the journey, I'm going 3x along here, 1x along here, another 3x, then another x. So my expression would look like 3x plus x plus another 3x plus x. That's the distances I'm covering on my journey around here. 3x, x, 3x, x. Add them all together because these are like terms, and I end up getting, let's see, I got 3x's plus another one is 4, plus 3 is 7, plus another one gives me 8x. So an algebraic expression for the perimeter would be 8x. All right, this question is just a substitution one, but I've got two substitutions to make. X equals -2 and y equals -3. So I'm going to rewrite the expression, and I'm going to leave gaps where each of my pronumerals are. Okay, so I've taken out the x and left a gap. I've taken out the y and left a gap, and now I'm just going to simply put in the values for each of those letters. So x will be -2, so I replace the x with -2. Y was -3, so I put that in there. Now I can go through and I can just use my order of operations. Remember BIMDAS from previous years, which says we do the brackets, then we do any indexes, multiplication, division, addition, and subtraction. So make sure I do this in the right order. Is there anything in brackets? Yes, but I don't have to do anything to it. They're already tidied up. Are there any indexes? Yeah, there is. I've got this one here. So I'm going to do this bit first. And this is where the brackets come in handy because I'm doing actually -2 all squared. Without the brackets, people would end up doing 2 squared and just leave the negative sign. So I'm going to say -2 times -2 becomes 4. So I've got 3 times 4. And having a look at this, is there anything I can tidy up here? Well, yeah, a negative and a negative together make a positive. So I'm just going to tidy this bit up while I'm here. Now that leaves me with 3 times 4, which is 12, plus another 3, gives me an answer of 15. Okay, so I've substituted each of those values to get an answer of 15. Don't forget to use the brackets. Look, here's why. I might as well just quickly show you while we're here. If I took this bit and just wrote 3, -2 squared, minus -3. So I've done the substitution, I just haven't used the brackets. A lot of people do this. They look at that and go, 2 squared is 4, so I end up with 3, -4, plus 3. And then they start to panic and get confused and like, well, 3 minus 4 is -1, plus 3 gives me 2, which is not correct. So the brackets just help you realize that we're multiplying here, and I'm also multiplying a -2. Be careful. All right, this is a proof question. I want to prove these two things are equivalent. The best way I can do this is just first of all tidy up all my like terms, and there are a few. So let's go through and do that. If I was to do this side first and tidy it all up, I get, let's see, my like terms, I've got 10x's, I've got x's, I've got y's and y's. So let's tidy up the like terms. 10x plus 7x gives me 17x. Let's get the pen, 17x. And my y's, 5y plus 2y gives me 7y. That's this side. What about on the right-hand side? Let's see if I can tidy up some like terms there. I've got 20x, take away 3x, leaves me with 17x. I've got 10y, take 3y, which leaves me with 7y. And what do you know? These two things are the same. So therefore, we've proved it. All done. They are the same thing. Once we tidied up the like terms, we can see that they are exactly the same expressions. All right, expand and then simplify. So there's two parts. First, we're going to do the expansions, and that's just the distributive law. So multiplying the firsts, the number outside the brackets, by each of the terms in the bracket. Once we've done that, we'll tidy up any like terms. So 3 times 2x gives me 6x. 3 times negative 2 gives me negative 6. Negative 4 times x gives me negative 4x. And negative 4 times positive 3 gives me negative 12, because a negative times a positive makes a negative. Do I have any like terms? Yeah, I do. I've got 6x and 4x. I've also got some constants, so I can tidy those up as well. 6x takes 4x, just leaves me with 2x. Then I've got negative 6, take away 12. So I'm starting at negative 6, taking away another 12. I end up at negative 18. Happy days. All done. All right, simplify this through factorization. All I can say here is don't freak out. I know this looks a bit ugly, but if we go through and just factorize, because it's given us the clue, it says through factorization, something might drop out for us. So let's go through and just factorize the top and factorize the bottom, because 3x plus 6 has a highest common factor of 3, because that fits into both 3x and 6. So I'm going to bring that out the front of the brackets, and inside the brackets I get x plus 2. Okay, because if I look at that, 3 times x gives me 3x, and 3 times 2 gives me 6. I factorized the top. Let's do the same to the bottom. If I factorize the bottom, I actually get 5 outside of x plus 2, because my highest common factor is 5. 5 times x gives me 5x, and 5 times 2 gives me the 10. Now I notice something pretty funky. I've got a common factor on the top and bottom. It happens to be this bit in the brackets. I've got x plus 2 on the top, x plus 2 in the bottom. It's inside brackets, so this is multiplication. So this is 3 times that. This is 5 times that. So I'm free to go ahead and cancel those out, because they are common factors. Remember, I can cancel common factors, and all that leaves me with is 3 over 5. We've simplified it through factorization. All right, sometimes in exams you can be your own worst enemy, and people can freak out about things that aren't freak outable about. That's not a word, but it is now. So this one here, you can look at it and go, oh, distance, they can see above the horizon, oh, meters above sea level. I don't remember doing anything about sea level, blah, 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 blah. But just stop, take a breath, read the question. They're giving you the formula, so it's just a substitution question. Okay, all this other guff is just sort of making the story around this. We've got a formula for D, and they're going to tell us to find out, or ask us to find out D when H is 18. So all we do is substitute H for 18. So this is a substitution question. I'm going to rewrite this just so I've got a little bit more space. The square root of, now instead of H, I'm going to put a bracket, because I'm now substituting H with the value 18. So I can put my 18 in there. Now I can work this out. This is just numbers now. I can calculate this. So I can do 5 times the square root of 9. I beg your pardon. Look, you could do this in your calculator if you wanted to, but I happen to know that the square root of 9 is 3. So I've actually just got 5 times 3, which is 15. D equals 15. Okay, that was it. It was just substitution, even though it looked a bit scary to start with. All right, the question 32. Look, this is the one before. We just did this bit, but I realized there was a second part to it. So scratch that. We've just done that on the previous question. But this time they want us to find out H when D equals 10 kilometers. Now, there's a couple of ways you could do this. You could rearrange the equation first so that it ends up with H equals something, and then do the substitution. Or you could do the substitution first and then figure it out. I'm going to do it that way. So I'm going to replace my d with 10, because that's what I'm told, when d is 10 kilometers. So substitute 10 where the d is. The rest of the equation stays the same, equals 5 times the square root of h over 2. Now it just becomes an algebra question to solve for h. And I'm going to go through this logically step by step. Our goal is to get h on its own. First thing I'm going to do here is get rid of this times 5. The opposite of timesing by 5 is divide by 5. Do the same to both sides because they cancel out. My left-hand side now is 2. And on the right-hand side, I'm left with the square root of h over 2. The trick here is knowing what's the opposite of square rooting. Well, the opposite of square rooting is to square. So now I'm going to square both sides. So I'm going to 2 squared on the left, and on the right-hand side, by squaring it, all I do is I get rid of the square root sign. So that's a really handy trick to know. The opposite of square rooting is to square something. So if you want to get rid of a square root sign, just square both sides, and you end up with just what's in the middle, and the other side obviously gets squared. So now, let me just run out of room here. So I'm going to move up to here. We're left with 4 equals h over 2. We're nearly there. The opposite of dividing by 2 is times 2. So I do that to both sides, because then they'll cancel out. And I'm left with 8 equals h. So therefore, my height equals 8. Okay, the algebra there was just, that was probably the biggest trick there, is just to know that the opposite of square rooting something is to square it, and we've just worked our way through until we've solved for h. All right, multiply and simplify this. Now, I know this looks ugly, but hopefully you remember from previous years, when we multiply a fraction, it's easy. We just multiply the numerators together, and we multiply the denominators together. All right, so this bit here goes on, this will be our numerators, this will be our denominator. Just because we've got algebra and pronumerals, the rules haven't changed, we just multiply them together. So on the top, I'm going to get 2w times 3w cubed. On the bottom, I'm going to have 12y times 8y squared. Let's see, now I can tidy those up. Let's do the numbers first. So 2 times 3 is 6. Now I've got this w multiplied by w cubed, means I've got w to the 4. On the bottom, let's do the same thing. Let's do the numbers first. 12 times 8 is 96. And I've got y times y squared, which gives me y cubed. I could leave it there, but there is a little bit more simplification I could do. I'm going to take it one more step. Is there a common factor here between 6 and 96 that I could tidy up? In other words, does 6 fit into 96, or is there a common factor for both of them? Let's think about it. And the way I'm going to approach this is ask myself, well, does 6 fit into 96 at all? Well, let's think about it. 6 times, it does. 6 times 16 is 96. So there is a common factor. So in other words, I'm going to divide both of these by 6. So that ends up being 1. 6 divided by 6 is 1. 6 into 96 goes 18 times. Sorry, it goes 16 times. So now on my top, I've just got w to the 4. And on the bottom, I've got 16y cubed. And that there is my answer. 2 to go. Consider the following graph. Part A. You see it's worth 2 marks here. So there must be 2 parts to this question. Read the question carefully. Will the gradient be positive or a negative value? So in other words, is the slope of this line, which is our gradient, is that positive or negative? Now we happen to know if it slopes up to the left, then it is negative. Okay. Don't stop there though, because the second part of the question says y. So you'll need to write something like slopes up to left. Okay, so you need to put the second part to get the second mark. What is the y-intercept? Well, we know y-intercept is where our line cuts the y-axis. So as I look along the y-axis, I can see it cuts the line right there at the point positive 3. So the y-intercept is positive 3. Write the equation of the line. All right, I'm going to do that bit up here. Let's take a little bit more room. We know the gradient intercept form of a line looks like this. Y equals mx plus b, where m equals our gradient and b equals our y-intercept. Now, one of those we already know, one we're going to have to work out. We know that our y-intercept equals 3 because we just worked that out in the previous question. Can I work out the gradient? Well, yeah, I can. Remember the gradient, I just take any 2 points on my line, create a little right angle triangle, like that, and that gives me a rise and a run. And you'll remember that our gradient equals rise over run. Now, my rise in this case, I can see that in this triangle that I've created, it rises 2 units. It goes from 1 to 3. So my rise is 2. My run in this distance along this little right angle triangle that I created between the 2 points is 1, 2, 3, 4. So it is 4. My gradient, I can simplify that down to a half. Now, be careful. The gradient isn't a half because we said it's a negative gradient because it's sloping up to the left. So I just need to make sure I remember to put the negative sign in that. So in other words, my gradient equals negative a half. I've now got everything I need to create my equation. Y equals, we said the gradient was negative a half. So y equals a negative a half x, because the gradient is the value in front of the x. And then my y-intercept, which we said was plus 3. That there, folks, is the equation of that line. Y equals negative a half x plus 3. It has a gradient of negative a half and a y-intercept of 3. Awesome. What will be the x-intercept value? All right, well, the x-intercept is where the line cuts the x-axis. So somewhere this line is going to keep going and it'll cut the x-axis. All right, you could do 2 things. You could look at this, and I'm going to see if I can extend my line here. Ooh, that was a terrible line. But all right, we'll go with it. I'll try again. I'll try and get a little bit neater. I could use a ruler, which I don't have. Let's pick the right pen. And go something like this. And I can see, if I guessed it correctly, or if you did this in a test, you could probably guess that it's going to cut the x-axis at x equals 6. I can be a little more accurate than that though, and I can say, well, hang on a second, the x-axis is when y equals 0. Because if it cuts the x-axis here, the y value is going to be 0. It's kind of like the opposite idea of the y-intercept. The x-intercept is when y equals 0. So all I can do is just simply substitute y equals 0 into my equation and find an x value that makes it true. Let's do that. So I'm going to say my equation now looks like 0 equals negative a half x plus 3. Now I want to get x on its own. So I'm going to take 3 from both sides. So I get negative 3 equals negative a half x. Finally, the last bit is divide both sides by negative a half, and I get negative 3 divided by negative a half equals x. Now you could do this knowing some rules about fractions, but to be honest with you, just punch that in your calculator in your exam and you'll get a value of, hopefully, 6. Therefore, x equals 6, which kind of lines up with my guess from earlier. So that's all good, that makes sense. But here I was just doing it properly, I guess, is the word. And finally, we've reached the last question for this video. I know you're sad about that. Sketch the line for the equation y equals 3x minus 3. All right, some things we know. Remember, this looks like it's in the right form. Y equals mx plus b. So I've got an m value and I've got my b value, my y-intercept. Oh, this should be easy because I only need 2 points. The first one's a given. The y-intercept is at negative 3. Okay, because I can see that straight out of my equation. My y-intercept is at negative 3. So that's down here. My gradient is 3. So 2 options. I could say, all right, that means for every 1 I come across, I go up 3. And that means my second point is there. And I wonder if I can draw a line and this thing. Let's have a look. That means I could draw a line that goes through those 2. Awesome sauce. Then it's done. The other option would be to actually say, all right, well, what's my y value when x equals 1? Okay, so I can actually say, all right, well, I've got my first point here when x equals 0. What do I get when x equals 1? I can just substitute that in. So y equals 3. I'm going to substitute. So I'm going to leave a gap and replace the x with 1. Y equals 3 times 1 is 3. Minus 3 equals 0. So when x equals 1, y equals 0, which gives me a coordinate. Because remember, this is my x value, and this is my y value. So the coordinate 1, 0, I go across 1, up or down to 0, and it ends up being that point there, which is the same one as we got previously, so that's a good sign. That is it. Line sketched. Exam done. You guys are awesome. Cheers.